Fabulous Chemistry Faithful, video 3. Let's start acids and bases. Today we're going to get into both acids and base theories. We'll get first into the Arrhenius acid, the normal, original theory, and then we will get into the alternate base theory, Bronsted-Lowry, so that we can understand fully what's going on. So what on earth exactly are these acids and bases? We have some reference tables, by the way. Acids are compounds that react with water to produce an acidic solution. It's a very generic definition, man. Okay? Bases are compounds that react with water to produce a basic solution. Okay, and now here we go to Arrhenius theory. And while I'm doing that, I'm opening it up to page 6 of my reference tables. We got a 1, a 2, a 3 of these reference tables that we're going to be using. The one's called common acids, one's called common bases, and the other one is the acid-base indicators. So we will probably get into table K and table L a little bit. Acids are compounds that release H plus or H3O plus. Remember, they are exactly the same thing. You're going to see this a lot. As the only positive ion in solution. This is what Arrhenius came up with what an acid is. And then bases now release OH minuses. And that release OH minus is part of the definition that implies that OH is in the molecule somewhere. And most of them are on here with OH. So if you look at the first three, y'all see that? The first three, I got NaOH. Notice there's OH in it. And KOH, there's an OH in it. And CaOH. And these things are going to dissociate into OH minus and Ca plus, and OH minus and Na plus, because bases are compounds that release OH ions into solution. This is the Arrhenius theory. This particular GIF is showing you again that H3O plus and H plus are the same thing. If one is there, the other is there. Okay. So formation of H plus, this is what's going on. I have HCl plus water. Okay. The H leaves this HCl and goes onto the water to make H3O plus, and then the Cl minus is floating around. I could write this another way. Let's see if I do it another way. Nope, go right into bases. So I could write this another way. I don't have to write H3O plus. I could say HCl plus H2O goes to H plus Cl minus plus H2O. But I know this and this together make that. So either way we write this, it works out the same way. I have no idea why I picked up the green marker and it wrote in red. But, there's somebody messing around with my computer. Okay, there we go. And so next we're going to get into base. Same thing's happening here. Here's another picture. You're going to write this in there, at least in chemical formulas. NaOH goes to Na plus OH minus. And notice that OH minus directly came from that base chemical of NaOH, which is the Arrhenius theory. Okay, but there's some problems. We're going to get to them. So again, one more time, general rules. Acids produce H plus ions as the only positive ion in solution. And H is usually the first element in the chemical formula. Handy dandy reference tables. Notice as we look down, they all start with H, almost all of them. And even the ones that have multiple ways to write it have one of them with H starting there, right? The compound out. Bases produce OH minuses as the only negative ion in solution. OH usually ends the chemical formula. There was 3 I already showed you. There's one that doesn't have OH in it. Okay, so there is a base that doesn't have OH directly in its formula, so it can't produce OH directly. That would be this guy on the bottom here, NH3. That's that ammonia that we were just talking about in the vocab video. So another theory was developed to kind of compensate for this new idea. How come NH3 is a base when it doesn't have OH in it? So alternate theory was needed to explain this behavior. Compound like NH3. It's a classic example. It's the one you're going to see a lot. If they're going to test you, they're probably going to test you on this one. All right. It doesn't obviously contain an H plus or an OH minus. Those H's on the end are not necessarily H pluses. Okay, so now I get to the Bronsted-Lowry acids, or the alternative acid theory. So those go back and forth, so you got to make sure that those things stay together. The alternate acid-base theory is called Bronsted-Lowry. Okay, so they're synonymous. Any compound that donates an H plus, which sounds a lot like the original theory, produces H plus, donates H plus, sounds very much like the same thing. Not changing there because, again, we're worried about this base that's a problem. And so what we did, or what they did, was they redeveloped the definition for a base to now say anybody that accepts an H plus ion has been donated by an acid. It actually takes it off of a water, leaving an OH behind. Okay? Here's what's going on. So I have NH3 plus H2O goes to NH4 and OH. And here's where this OH was not in this NH3 molecule. There's no OH in there. These are cool, like three-dimensional pictures, you know? And all of a sudden there's OH present, so that OH present is going to make it basic because now there's more OH minuses than there are H pluses, and now it becomes a base. So NH3 is actually a base, even though it doesn't have OH in it. So what it does is it accepts a hydrogen off of a water molecule, creating a leftover OH minus. That OH minus now makes it basic with its interaction with water, and it doesn't produce it directly, it produces it indirectly. Okay? So identifying acids and bases. Here's the reference table I've been trying to show you. These are the bulk of them that the Regents will ask us about. Are there other acids? Yes. This is not all of them. I have never seen the Regents exam ask you to actually name or use another acid that's not on this list. It might be in like a paragraph about something that is a distractor, but it's not actually something you're actually using to do a double replacement with or anything like this. So HCl plus water is going to make H plus Cl minus. That H plus, because it makes the H plus, that's what makes it the acid. Okay, is there another one? Yeah, buddy. Sulfuric acid, H2O. This is called a diprotic acid, by the way, because there's two H's. Makes two H's, we call that a diprotic. Two protons. Remember, H plus is just a proton. Diprotic acid, sulfuric acid. Then we have this other reference table right below, which is the bases. And NaOH becomes, whoopsies, too fast, Na plus and OH minus plus the water. So now I make OH minus in solution, and that is why it is a base. Even straight up Arrhenius theory. But also what happens is it'll end up accepting an H plus somewhere along the way also, because acid bases are H plus acceptors also. And with that, oh my God, finally finished. Video 3 is done. On to video 4 next. Let's see what that's all about.